Hello there, and welcome to the Bitcoin Takeover podcast. I am Vlad, and today I have an interview with the man of the hour, the creator of the most promising innovation in Bitcoin, which is truly permissionless and opens up the door for a lot of smart contracting and Turing complete operations, which previously were considered to not be possible on Bitcoin. His name is Robin Linus, and he is also working on Zero Sync. I was gonna call it ZK Sync, but it's Zero Sync. And he did something which is super unpopular among Bitcoin developers, because if you ask Peter Todd to look into something that was researched by the Ethereum developers, he's gonna say, I don't want to legitimize a scam. But it seems like Robin was able to look and find something that's actually interesting and worthwhile and bring this virtual machine into Bitcoin. And we're gonna talk about this, Robin. So welcome to the show.
Hi, thanks for having me.
So first of all, I have to ask you, Robin, why BitVM? Why does Bitcoin need anything like this?
My main concern is I want to see Bitcoin scaled. I want it to scale to for everyone to be used as a currency. And currently that's not possible. And one idea how we can scale it is if we had some kind of two-way packs such that we can pack it to other systems like sidechains or ZK rollups and stuff like that. And that's why I was trying to find ways to somehow verify something like a ZK peep on the main layer without having to change Bitcoin. And the end of the journey was BitVM.
So ZKP stands for Zero Knowledge Proof. Yeah. What is that, and why does it matter for Bitcoin?
The second question is easier to answer, and it helps to answer the first question, which is the security of Bitcoin as a decentralized system stems from the fact that everybody verifies everything. If everybody verifies all transactions of everybody else, then everybody can be certain that nobody cheated. And that is actually quite trivial, but this is how you get decentralized security in the Bitcoin system. However, it scales very poorly, because if everybody has to verify everything everybody else does, then that's a lot of work for everyone. And that's the fundamental scalability problem of Bitcoin, or in general, decentralized systems, everything you call blockchain, also everything runs into that problem. And zero knowledge proofs, they come in quite handy. Originally, they have been invented for privacy reasons, but people have figured out quickly that they are also quite interesting for compression, because you can use a zero knowledge proof to compress almost infinite amount of computation into a constant size proof. We call these SNARKs, succinct arguments of knowledge. Succinct non-interactive arguments of knowledge. They are a form of zero knowledge proof, a particular succinct form of zero knowledge proofs, and they allow us to compress essentially infinite amount of computation into such a succinct proof. One interesting application is what we do at ZeroSync, which is we implement a chain state proof. That means we run a Bitcoin node in such a proof system, and then at the end we get like a receipt that was the result of it. And that means we only have to verify the blockchain once, and then we can prove we have a proof for the resulting state, and everybody else can verify easily that this is actually the correct resulting state without having to do all the recomputation themselves. And this is a way to compress the blockchain a lot, which helps a lot to solve the fundamental scalability problem of decentralized currencies, which is that everybody has to verify everything, because this way it becomes very cheap for everyone to verify everything. And that is probably a fundamental tool for us to scale Bitcoin.
I can see this as being super useful for mobile wallets, which right now are mostly SPV. You connect it most of the times to someone else's Electrum node without even knowing. Sometimes it's random, sometimes it's arbitrarily imposed by the developer of the wallet. And with a zero knowledge proof, you could be able to synchronize your own node in a way that's fast and scalable and minimized for data usage.
Yeah.
But I was thinking that the classical Bitcoin orthodox reply to this is going to be, no, if I do computation and I verify everybody else's transaction just the way Satoshi envisioned, is more secure than using some shitcoin technology that was created for Zcash, which is a shitcoin because, of course, it underperformed Bitcoin. So what's the answer to this?
Yeah, there's certain levels to it. Like, I mean, to some degree, I just agree with the fact that it is not just as secure as using Bitcoin Core in the conventional way, because simply by introducing all this complexity and all this new complexity that is not battle proven, you do open up ways for the system to fail that were not possible before. So there can be new sources of catastrophic errors. So it is definitely not. I cannot just wave away these concerns. On the other hand, there doesn't seem to be a fundamental problem with this approach. Like the math behind it seems to be very sound. It has been analyzed by lots of cryptographers, that don't have a stake in some particular shitcoin. And also there are like bounties essentially, because shitcoins are running these things. And this is essentially a bug bounty to see if the math behind it is sound, because if it was not sound, then there would probably be people who would break it. And the fact that they don't break, that these systems are running, and that they, even though they are shitcoins, there is real money involved. And the fact that they are not breaking means that there is something to the cryptography behind it. And the tool, even if it's from the shitcoin world, is definitely very, very exciting. And it's like a fundamental technology, and it would be absurd not to use it if it's that superior than anything we had so far.
Yeah, and you also did something controversial with computation, which this idea of Turing completeness was sort of a big deal in 2016, 2017, 2018. It was all about this label that was used sort of like a promotional tag or something like that. People were saying, oh, is this blockchain Turing complete? And now you have created a way for Bitcoin to be Turing complete, but with off-chain computation. And why is this necessary at all? Why do you think it's useful for Bitcoin?
Yeah, first of all, this is a very different thing than the ZKP approach. With like the ZKP approach, we applied this zero knowledge proof technology to compress the blockchain, but the BitVM is actually something new. It is kind of related, but it's a very different concept. And yeah, it is related in the first place in the sense that we would love to have a ZKP verifier on Bitcoin, because that would allow us to have like sidechain systems or side systems like ZK rollups and yeah, all kinds of other systems that might scale better than the main chain does. And have these side systems and roll them up into Bitcoin such that they only interact with the main chain once in a while, but you can still use BTC very efficiently in other systems. That's the main idea behind it. And yeah, the end goal of all of this is infinite scalability, or like, for all practical purpose, infinite scalability. I think Bitcoin should be really as simple as sending an email, that everybody can send trustlessly Bitcoins around all the time, just like you can send an email and it costs you nothing. And it's like absolutely as simple as it gets. It should be as simple as paying in the supermarket. Like you have your phone and you tap it and that's it. That's everything there should be to trustlessly use Bitcoin. And I think that's possible if we just can scale payments far enough with sidechains and similar systems, side systems. And the essential problem that we have to solve is a so-called two-way peg, like a way to peg Bitcoin to some other system without relying on trust. We can already do it with relying on trust. A popular example, or like a popular example, a well-known example is Liquid, and there we just use a federation, like a multi-signature, and we trust the multi-signature that they don't run away with a BTC that are pegged to the sidechain. But we would like to do better. Yeah, we would like to have a trust minimized system, or ideally a trustless system. And yeah, BitVM, the main purpose of BitVM is to have some kind of trustless or trust minimized bridge into other systems, especially sidechains.
I didn't tell you this before we started the interview, but during the same season, which is season 15, which conveniently and also coincidentally coincides with Bitcoin's 15th birthday. It's just that I got to number 15. It's just a nice coincidence. But I've interviewed Super Testnet in the same season, and your episodes are going to get published at the same time. And he said something very cool and nerdy that he wants to do with a game of Pokemon. And basically, he wants to create this multi-sig where you can unlock the key if you play an off-chain game of Pokemon and you, for example, find Pikachu or something, and that unlocks the key to sign the transaction and claim the funds. And he said this is possible specifically because of BitVM. And what do you think about this use case? And also, can you think of something similar that you can do, like not similar, but something else?
Yeah, like I mean, theoretically, there's lots of ways that you can use BitVM for, because, yeah, as the title says, you can use it for essentially any kinds of computation. But as I've already mentioned, I think payments and scaling payments indefinitely, that's the really interesting use case. And that's the thing that I'm focusing on. And that's what I focus all my efforts on, because I think that's a use case that makes sense from a lot of perspective also, because since you have to pay fees on chain, or like you have to be able to pay fees in the worst case, that's slightly different. You don't necessarily always have to pay them. Usually you don't pay them because people will be honest, as they are disincentivized to act dishonestly. So it's unlikely that they act dishonestly because it will cost them a lot of money. So they will probably be honest. So there won't be that much fees, but you still have to be able to pay the fees for the incentives to work out. If you're not able to pay the fees in the worst case, then the incentives won't work out, and then BitVM doesn't work. So it works only for high value use cases, which is given by by a bridge, for example. If you're bridging, I don't know, 100 Bitcoin to some sidechain, then there is lots of incentive to pay some fees to guard that 100 Bitcoin. For some small entertainment things for individuals, like that I play some Pokemon game and then I will pay on-chain fees to guard that, I don't think it will work out in the long term. Like as we can see now, the fees are rising, and if Bitcoin works, then the fees will have to rise even more, and I don't see how that would really work out in the long term. But I do see that it works really well for bridges, and then you can have sidechains, and then you can do anything on a sidechain that you can imagine that is possible. You can do anything that is possible on any other coin, or anything anybody else does on any blockchain.
Oh, it sounds a bit like drive chains, if you ask me, because that's also the value proposition for it.
It's totally like drive chains. Like I like drive chains in general. I'm very interested in this idea of two-way pegs, and the most mature proposal for a two-way peg on Bitcoin is drive chains, and I totally support it. Like I like Paul's work. I think he's doing a great job. I admire his patience. I admire his endurance, how he keeps fighting for his idea, even though it's not resonating that much with as much as it should resonate with other people, I think, or with the community in general. And since BitVM is essentially a workaround to enable drive chains without a fork.
Yeah, permissionless is the name of the game. This is how many of the innovations in Bitcoin have been brought.
Wasabi Wallet is unfairly private. It's the most advanced, most used Bitcoin privacy wallet, with 500,000 downloads across Windows, macOS and Linux, as well as thousands of fresh and new Bitcoins get mixed every month. Wasabi makes use of the new generation Wabi-Sabi engine to create mega conjoins, thus mixing your Bitcoins with those of hundreds of other users. For amounts lower than 0.01 BTC and remixes, you pay no coordination fee. If you don't use your conjoins, Wasabi Wallet has a native Tor integration and downloads block filters to help you keep your network level and public key privacy. Download Wasabi Wallet for free today at wasabiwallet.io and experience the future of Bitcoin privacy. Future of Bitcoin privacy. Future of Bitcoin. Future of Bitcoin. Future of Bitcoin. Future of Bitcoin privacy.
And another question that I have for you right now is, why was BitVM released at this point? What was it that was required for this virtual machine to exist on top of Bitcoin?
Do you mean like technical updates such as Taproot or SegWit or something? Or do you mean like what was the underlying idea that was key to,
I was getting to the point where maybe the emergence of ordinal inscriptions gave you some idea, maybe?
I'm not sure if it's that way, because like I've been thinking about Bitcoin scripts way longer than ordinals existed, and I think already in 2021 I started building a GitHub repository with like all kinds of exotic Bitcoin scripts and like all the crazy things that you can do in Bitcoin script, and that some people knew, some other people didn't know. Like I tried to find I tried to build like a collection of the things that people know, and I tried to add some new things. And I was already very aware of the facts that you can have infinitely large scripts and stuff like that. And I was already thinking about what to do with it, together with Super Testnet. Actually, we kind of together, like I invented a way to do kind of efficient bitwise XOR operations, and Super Testnet then used it to implement most of SHA-256 in like low-level script. And that was already when we started talking about how big Bitcoin scripts can be, and that there is no limitation for Taproot scripts and stuff like that. And I think it might be even have been the other way around, that we have been discussing that publicly in the Sidechains Telegram channel of Ruben Thompson, which has like 500 users and many Bitcoiners are in there. And I think other people might have heard us talking about what we can do without the limit. And then later, ordinals have been invented after that, after people started thinking about it when we talked about it publicly. It was not before.
Yeah, it is just that whenever people defend the existence of ordinal inscriptions, they will say that they can use the exact same scheme to create rollups. And that might be a use case.
Yeah, I don't think so. Like, I mean, it depends on what you mean by that. Like, yeah, you can just inscribe some kind of data into the blockchain to have some kind of rollup, but it doesn't solve the fundamental problem that you want to pack BTC to the sidechain, right? And you need some kind of bridge, and just inscribing something into the blockchain and some kind of rollup into the blockchain doesn't mean anything really. It doesn't connect your sidechain, your ZK rollup token with BTC natively. That is a fundamentally different thing. Does that make sense?
Maybe the direction in which I took the question was a bit clickbaity, but you're going to mention something about how SegWit and Taproot and possibly these optimistic rollups have helped the creation of BitVM.
Yes, somewhat. Optimistic rollups, definitely. Like the ideas of like in the Ethereum community, we see that very often that there are two ways to solve things: either optimistically or with like a ZK rollup thing, or like in general with a validity proof. And there are many projects that do things optimistically on the Ethereum sidechain, and it seems to work in many ways. And that was definitely an inspiration for BitVM. Yeah.
It's pretty cool, if you ask me, that there is something interesting that came out of Ethereum, which until a few years ago was a complete joke, but it seems like they used the money that they made from, selling money with the foundation to pay researchers, and they got some serious developments that are actually interesting right now. And some of it can come into Bitcoin, but it took someone to actually look into that and find something that's useful for Bitcoin and can be implemented into Bitcoin. And honestly, I'm happy that you're part of this new generation of researchers who don't care where it comes from, because it's cryptography. And as long as it's compatible and it's proven to work, you're going to make it work for Bitcoin. Because as I said previously, there's the old generation, the old guard, who label these projects as scams, and they think that looking into anything related to them is going to legitimize the scam and perpetuate it. But I like this. It's cryptographic research. It's crypto the way it's supposed to be, cryptography. Okay, no reply for that awkward moment. But honestly, what are some of your favorite use cases? Like, name 3 possible use cases for BitVM.
Yeah, as I said before, I see one major use case, which is bridging Bitcoin to sidechains and then having millions of transactions. Like every computer game, if they have whatever kinds of tokens or so, they should just use BTC derivatives or whatever on Bitcoin sidechains that are trustless, and where everybody can just create a new sidechain, and where you have a free market of sidechains where people can make offers to the market and say, hey, my sidechain has this, it has, I don't know, crazy good scalability and privacy, and then if it's attractive to the market, then people will honor it, and then this sidechain will grow, and other sidechains that have bad offers will just die off, and the market will evolve, and the technology can evolve, and people can be innovative. That is my main concern. That we can ossify the main layer. That is a very important thing. The main layer can just ossify, and we don't have to change it ever again. And then all the innovation and scaling it can happen on side chains and roll-up systems and stuff like that.
But you're talking about ossification right now, even though you mentioned that there is a specific soft fork that would improve the functionality of BitVM much more.
Yeah, I'm not saying that Bitcoin should ossify right now, but I'm saying we should solve two-way packs such that they are as trust minimized as possible, and then we can ossify the main layer. I think then it is a good idea to ossify the main layer, never change it again. But I think it's a horrible idea to think about ossification before we have solved two-way packs. I think that would kill Bitcoin. I think that would be extremely stupid and would cripple Bitcoin like crazy to ossify Bitcoin before we have solved two-way packs.
Yeah, I'm gonna play the contrarian here, but I hear people saying that using sidechains is an obsolete concept, and it's almost like stacking 56K modems when in fact we should be switching to broadband. And this is usually what the Lightning people say, that using blockchains to scale a base layer blockchain is an obsolete idea that's not worth looking into anymore.
I don't see that for many ways. Like, first of all, Lightning cannot solve the problem itself. Like, the Lightning cannot solve the main problem, which is one user needs at least one UTXO. So every user would have to be able to afford main chain UTXOs to use Lightning as it is currently. And that doesn't really scale well. I think it is already described in the Lightning white paper that current block size cannot serve all people on this planet on Lightning and stuff. They have already made these calculations that blocks would need to be like, I don't know, 100 megabytes or even bigger. And like Lightning is not the solution. It doesn't solve the problem. And I think there is not really any speculation about that. Also, it's just a fact that it doesn't scale enough. It does excel at other things, though. Like it would excel very much as like a settlement layer between different Bitcoin banks, whatever that means. Ideally, Bitcoin banks that are trustless and permissionless and that have all the properties of the main layer. And sidechains are the best solution that we have so far because they offer all the censorship resistance and all the nice properties that the main layer has itself, because they don't need a centralized party for them to run them and all that. And they offer lots of solutions without making many sacrifices, I would say. And on the other hand, the main layer of Bitcoin is not as optimal as it could be. Like we could easily define a main layer that is like 5 times more efficient or 10 times more efficient, and that means by spawning new sidechains, we can encode things more efficiently than we can encode them on the main layer. And that means even though blockchains don't scale, blockchains can scale better than the main layer does currently. So there is definitely value in exploring other layers to optimize these things, to optimize the throughput.
Yeah, that's a pretty reasonable explanation, even though the people who talk about sidechains and they use this context are not super reasonable. And I did listen to Peter Todd, who is against this idea of two-way pegged sidechains, and he believes that they increase too much the complexity. And also, he's not sure who's going to run the nodes to validate these. And it's going to make mining incentives very interesting because they can get fees from lots of places. Ideally, they should mine all of them, but there can be disagreements between miners and those who run the sidechains. I don't know.
Yeah, now we are getting in a lot of different topics because sidechain is not equal sidechain does not equal sidechain. I think the things that Peter Todd is saying, they are mostly directed specifically at the BIP300 proposal. And then also BIP300 is not equal BIP301, which is the consensus mechanism, and we can have different consensus mechanisms for sidechains. I'm not particularly a fan of BIP301. I am particularly a fan of my own, the consensus mechanism that I came up with, which is a Bitcoin-backed proof of stake algorithm, which means you stake Bitcoin in the Bitcoin main chain, and that makes you a staker, a validator of the sidechain. And that is fundamentally better than usual proof of stake. Usual proof of stake just tries to secure itself with itself, which is absurd, and I don't support that. But here we have something very different because we have the Bitcoin chain, which is anchored into proof of work, and it does all the operations on the staker set. You join the staker set in the Bitcoin chain, you leave the staker set in the Bitcoin chain, and you get punished in the Bitcoin chain. So you have that anchor into reality, and from there you can create sidechain consensus with a proof of stake algorithm, and then you get all the advantages of proof of stake algorithms, which is like super quick settlement finality. Like it becomes very quickly very expensive to change a final block, even quicker than in proof of work, because there is that interesting asymmetry in proof of work. The cost of block production equals the cost of attacking the chain. in a stake chain, in a proof of stake chain, the cost of block production is just the time value of the stake, whereas the cost of attacking the chain, if the chain is sound, costs you the stake itself. And that is exponentially or like fundamentally more expensive. It's orders of magnitude more expensive to attack the chain than to produce the chain. And that gives you a very quick settlement finality. So transactions settle very quickly on such sidechains. And you can also, of course, have like a very high block rate that you cannot have with merge mining, for example, without harming the value of it, or like the hardness of a block. Like if you have a merge mine block, then if you have 15-second blocks, then the proof of work in a single block is very small, because otherwise you cannot produce them every 50 seconds. On the other hand, in a proof of stake sidechain, you can have 50-second blocks, and once they are final, and it's extremely costly to change them. Because if the system is sound, which we assume it is, then you can slash 1/3 of the stakers if they ever rewrite a final block, and that gives you very nice properties that BIP.301 doesn't have, and that is the question about the consensus mechanism. But the question about the consensus mechanism is not the same question as the peg mechanism. The peg mechanism is what BIP.300 is about, and BitVM is a workaround for BIP.300. It is a way to facilitate the peg. And I'm not advocating for merge mine sidechains. I think proof of stake sidechains, Bitcoin-backed proof of stake sidechains, they are better.
I can see how this is gonna be even more unpopular among Bitcoiners just because they hate proof of stake and they associate that with Ethereum. And they're kind of like, oh, you're trying to bring shitcoins into Bitcoin. And that's where they're going to stop looking at the project.
But I feel like that would be stupid, because I'm really accepting, like I wrote that paper, and it really starts with all the observations of people like Andrew Poelstra. Andrew Poelstra wrote that beautiful paper about why proof of stake is impossible. And it really, my paper starts with these ideas why it is impossible to really have a decentralized proof of stake, and explains why anchoring proof of stake into proof of work solves exactly the problems that Andrew Poelstra points out in his beautiful paper. And if you think that's a scam, I don't know.
No, I'm just referring to the average person out there. They don't look into previous research. They don't care about arguments. They just see some words such as proof of stake. And when they see that, oh, you're trying to attack Bitcoin by making it proof of stake, of course.
Yeah, I got that response a couple of times when mentioning my work. That's true. But I don't know. I think we just have to build it and then see.
CryptoSteel offers a durable, physical backup for cryptocurrency key and recovery words. These user-friendly cold storage devices withstand harsh conditions, including fires, floods, and earthquakes. Made from the finest European stainless steel, they are built to last. Accessible to all and requiring no computer skills, the original CryptoSteel cassette and capsule have been innovating Bitcoin security since 2013. They provide a reliable and robust backup, essential for the safety and longevity of your digital investments. Ideal for protecting your digital wealth. CryptoSteel isn't just a one-trick pony. Of course, it works with your BIP39 seed phrase, but you can also use it for important passwords, Bitcoin core passphrases, Nostr private keys, and much more. Buy your CryptoSteel metal backup today from CryptoSteel.com and use promo code BTCTKVR to get a 10% discount. CryptoSteel, secure your Bitcoin like an OG.
Yeah, I told you, I think this is going to be even more unpopular than BIP.301, which has some objections on a political level. I think the most common way to criticize it is that it adds a layer of human politics into the whole situation. But if you add specifically the word proof of stake, maybe rebrand it, call it something else. But if you promote proof of stake into Bitcoin, you're only going to run into roadblocks and people saying, oh, you're trying to turn Bitcoin into a shitcoin.
Yeah. I don't know. I think we just have to
maybe call it oligarchy, which means those with most money. It might work better.
Yeah. I'm not quite sure. I think it's a matter of usefulness. I think the market, like it's not the people on Twitter that decide such things. Like if it would require forks, then yes. But I think when you can build it and when it's useful to people, then that creates value and that attracts usage. And if it's really a solution, then the market will not get around it. If there's a better solution, then the market will get around it at some point. But otherwise, you have to bias the market too extremely to get around it if it's actually that useful as I think it is.
Yeah, I mean, I understand your point. I don't have a strong opinion on it. I can't say that I like it or I dislike it because I had only a brief description of what it is. But at the same time, I've only told you that this one label, proof of stake, triggers people and is gonna make them reject the idea from the get-go without even looking into it. Oh, you're trying to bring proof of stake? No, we're going to oppose it, cancel it, whatever.
Yeah, it's very true. Yeah, I mean, I came up with the idea already 2 years ago or something, and I have talked about it with quite some people, and that reaction was not uncommon. I think certainly that word is not. If I had a marketing department, I'm pretty sure they would have good reasons to make me not use that word. And but to me, it's just like the right description of it. But maybe
because scientifically that's what it is, right?
Yeah,
it's just that these three words, proof of stake, they trigger some very emotional reactions in people.
Yeah. And I mean, there are other approaches where you have like this weird, we bridge BTC to our sidechain, and then we have that sidechain consensus mechanism where we have some kind of proof of stake that is backed by this wrapped BTC or whatever. And I think that's nonsense because that's the same problem as usual usual proof of stake, because it tries to secure itself with itself. I think it's crucial that in the proposal that I'm making, the entire staking happens in the Bitcoin main chain, which is secure as long as Bitcoin's proof of work is secure. And I think that's the fundamental difference that hopefully can make the difference in the real world.
I think you mentioned something very interesting earlier with the idea of everyone having one UTXO. Yeah. And do you think it's possible with BitVM in the future to create all of these two-way peg sidechains, but within a user interface where, depending on the size of the transaction, it automatically chooses the best way to have a low fee so that the user doesn't have to think about it? When the user pays, let's say for groceries, around $10, it's gonna be the cheapest bridged sidechain that exists. But if he wants to, for example, have privacy, maybe there's a button there to go to some Zcash or whatever Halo 2 type of sidechain. Or maybe if it's a large transaction and more security is required, it's gonna be an option for that. But in a seamless way where you don't have to think about which sidechain or which layer you're gonna be using. It's all within the same UTXO. Is that possible?
Very important part of these bridges is that I actually think they won't be used, but the fact that they could be used makes the sidechain work. That's similar to Liquid. Like in Liquid, very few users actually use the bridge because you can only bridge in high amounts and you can only bridge out high amounts. So that's usually not what the average user is using. What the average user is using is just atomic swaps between Bitcoin and the liquid sidechain. And those can be instant and very simple, and actually they can be completely seamless because you just need something like a Lightning wallet on the sidechain, and then you can seamlessly pay anybody else in the Lightning network, and it doesn't really matter to you if they are on the same sidechain or if they are on the main chain or if they are on a different sidechain or whatever. That can be all abstracted away from the user, such that there is just that single layer, the Lightning network, which connects all the main layer and all sidechains with each other. And I think that's the future. That's how it should be, like a free market of sidechains with different properties and different offers to the market, and they're all connected with the main layer and with each other via Lightning channels. And the end user would never use the bridge. Like, the bridge would be way too expensive for them. It would be way too slow. Only like some liquidity providers, they would peg in big amounts into the sidechain and then sell their liquidity to other people, and they would be the only ones who would ever use the bridge. And even they would use the bridge very rarely, because if they just want to balance out small amounts, they can use atomic swaps as well. So the bridge is really just used like essentially for the worst case, for like the case if the sidechain doesn't have much value, like if it doesn't offer much value to the market and nobody's using it, then the sidechain needs a way to die off. It needs a way for users to leave it, and then they can just sell back their coins to some liquidity provider, who then collects it and then leaves the sidechain, and then the sidechain dies and the BTC are back on the main chain. That's the only moment when you really need the bridge. For most other cases, you will just have atomic swaps and you can just settle via the Lightning network.
Yeah, when Lightning was first released, one of the main propositions for it was that it's blockchain agnostic, right? So you can run it on multiple chains and you're going to be able to make instant atomic swaps. But it seems like the research or the development of that was delayed. It did not become a priority anymore. There was, I think, an early atomic swap between Litecoin and Bitcoin. Litecoin was actually the first chain that sent a mainnet Lightning transaction, but it seems like development on Litecoin did not go any further. It was only used as a testnet with incentives. And we don't really have ways to do that right now, but it's really cool that you can permissionlessly peg out of sidechains using the Lightning network. You do atomic swaps and you clear your liquidity. You don't have to do that on-chain transaction.
Yeah.
You just get the liquidity on Lightning and then you can spend it or swap it for something else.
Just pay an invoice. Like that should be like the fundamental layer that everybody's using. You just show someone else an invoice, and it doesn't matter where they are, if they are on the same sidechain or on another sidechain or on the main chain. It's all the same. It's the one settlement layer for all of them, like the layer 3.
Actually, yeah, but also the situation that you described with multiple liquidity providers, it sounds to me more like Arc, something that they're trying to do.
I would say the fundamental difference between a sidechain and like Arc is cool. Like I am totally a fan of Arc. I'm a fan of the people behind Arc, and I like contributing ideas to Arc, and I really think Arc is cool, and it is definitely also a way to scale Bitcoin. And but I don't think it can scale Bitcoin long term, and it cannot scale Bitcoin to billions of users. It might be possible for Arc to scale Bitcoins to 100 millions of users, I think, but I don't think that it can easily scale to billions of users and beyond. And to really have almost no cost for a Bitcoin transaction, I think it needs sidechains. And the reason is that Arc or like any layer 2 that requires users to be able to settle on main layer. Any such system has a minimum amount of money that makes sense in that system. And the higher the main layer fees, the larger the minimum amount is. And I think, if the main chain fees are $50 or something, then it doesn't make much sense to have less than $500 or something in such a system. And that is already a lot of money that people might not, or like many people don't have access to. And in particular in the countries where there are unstable currency systems or unstable payment systems and stuff like that, that would profit the most from a cheap and reliable system that Bitcoin could be. They don't have that much amount that they could settle on chain. So I think any layer 2 that has to settle or that has to be able to settle on main layer is fundamentally limited, and that's why we need other layers where people don't have to interact with the main layer. And as far as I know, sidechains are the only solution so far. ZK rollups could be another solution depending on how decentralized the sequencers are. And I also came up with that other idea called ZK coins, which is another layer 2 protocol, similar to ZK rollups, but trying to solve a couple problems of ZK rollups, in particular the problems with the sequences. So this could also be a way to scale a bit more, but at the end you need more block space. And I think the only way to scale block space without bloating the main layer is sidechains, and I don't know any other solution for that as of today. That's why.
Yeah, these sidechains, as you described them, require fairly large blocks. And my question for you is there any ongoing research for this to get pruned after a year or two so that it doesn't get super bloated? Because I imagine that storage is going to get pretty expensive and unreliable for all of these sidechains. And there must be some way to make sure that they're not going to amass a lot of data, and every maybe Raspberry Pi validator is going to be able to also add a couple of sidechains that they want to validate at the same time.
I would think that users would validate at most 2 chains. Like they would validate the main chain, and they would like to validate the sidechain that they are on. They would not validate every chain. And there is nobody who needs to validate every chain. So BitVM would not require everyone to validate every chain, for example. But you can make chains much more efficient with, for example, the ZK coins proposal. You can scale throughput by a factor of 50 to 100 or so, and you can make payments much more private. And also, you make the validation, the verification of the blockchain much cheaper. So you can have much higher throughput with the same amount of hardware. So, for example, if you need X amount of hardware to sync the Bitcoin blockchain, you could have 2 times that hardware, and it could give you 100 times more throughput. So 2 times more hardware could give you 100 times more throughput just by using more and more compact encodings, essentially. And I advocate for these things, because we would just need, I don't know, like how much, 100 sidechains or something. I think that would suffice for the entire planet. 100 sidechains that are more compactly encoded than Bitcoin is, 50 times or 100 times more compact, and then that would be everything we need to scale Bitcoin as much as we need.
Yeah, that's interesting. This might be your Bill Gates 1990 statement, when he said something along the lines of 100 megabytes are enough for the entire planet. And you said 100 sidechains are enough for the entire planet. But I guess I hope we get fewer, not 100.
Yeah, I think it's a bit. I'm not quite sure that there is the communication problem, right? If you model all transactions as like totally random across sidechains, then it would mean if there are 100 sidechains, then the probability that you pay from your sidechain to your own sidechain is just 1 in 100, right? The probability that you pay out of your sidechain is 99%. And that would mean that most of all transactions would be cross-chain. And I think that is just too much overhead. I think it will converge more against that most transactions are not cross-chain. It will be easy to make cross-chain transactions, but they will always be a bit more expensive than on-chain transactions, and that will make markets gravitate to particular chains. And I think local proximity and stuff like that will lead up to people that live in the same places will be on the same sidechain or stuff like that. I don't see it being 1,000 or like 1 million sidechains. Maybe, but I think it's more complex. It seems the market would optimize that way, but I might be wrong.
Yeah, so it seems like the quote by Bill Gates is from 1981, and he said that nobody needs more than 640K, which is kilobytes of RAM. So that's more than half a megabyte of RAM. He thought at the time nobody needed more than this.
Yeah, our proving machine had, I think, like a terabyte of RAM. The machine we used to prove the Bitcoin chain.
Interesting. How much RAM does BitVM need for computation?
It's not much. Like, it's very cheap. You would run that VM. Like it's not really a slowdown in comparison to your laptop. I mean, there's like some slowdown, but not fundamentally.
Yeah, so I wanted to ask you this because I read recently a comparison that, what's his name? So there's this Italian developer who works on Edge Wallet. Oh no, I really wanted to quote him, but maybe I'm gonna remember his name later. So he said that the average SegWit transaction had with one input and two outputs, meaning that you make the payment from this UTXO, you pay this amount and you get this other amount in change. And the size of that is 220 bytes. And the size of a confidential transaction in Liquid is about 20 times larger. And this was David Cohen, that's his name. He said that this is the reason why we don't have confidential transactions in Bitcoin, because they don't scale. But it's not reasonable anymore, because I looked into the ZK stuff from Zcash, and people will say, no, it's a shitcoin, don't look into that. Oh, Zuko had this pre-mine and used this amount of coins and blah, blah, blah. But they have this Halo 2 system, which claims that within their pool of mixing or whatever they do for shielded transactions, the average transaction size is smaller than 200 kilobytes, which, not kilobytes, 200 bytes, which means that it's already smaller with privacy than the average on-chain transaction on Bitcoin with SegWit. And I think this is a pretty good breakthrough, because we have privacy and we have a point where privacy is not bloated, is not bigger than the average transaction, it's actually smaller. And I wonder if you have any opinion on this, if you took more time to look into it, and if you think that we're going to soft fork any of the Zcash compression technology into Bitcoin anytime.
Yeah, my opinion about that is mostly about ZK coins, the proposal that I came up with, which is based on ideas that are very similar to Zcash, but it's trying to solve various problems that I see with Zcash and also ZK rollups. And the idea is really, actually it's similar to RGB. RGB uses client-side validation, and client-side validation is an interesting concept because it fits the idea of moving as much as much off-chain as possible. Like, in general, it's a very interesting question. For us to make a transaction, what is the minimum amount of information that I have to somehow put into the blockchain for our transaction to be secure? And there's already in the Bitcoin white paper, it says that digital signatures and hashing almost solves everything about transactions. The only hard part is really the double spending. And when you really dissect that, you see that I can give you a coin and I can give you the entire history of that coin. And all the amounts and all the details of the transactions, they are not really relevant to the blockchain. All we need from the blockchain is some ordering, some sense of time, some notion of this happened and then that happened, and there is a clear this and then that, a clear arrow of time. And this is what we need the blockchain for. And that allows us to solve double spending. But we don't have to inscribe the entire transaction into the blockchain, because you, as the recipient of a token or as a transaction, you can validate on the client side the entire history of the coin that I just sent you. And it's not relevant if the rest of the world agrees with you if it's valid, because if it is valid, then it is valid. Like, you will come to the conclusion that it is following the rules that we all agree on. So you subjectively prove for yourself that it is valid, which is enough for you to be certain that when you give it to the next person, they will come also to the conclusion that this is a correct coin. And that means there is no global consensus needed if your particular coin is actually valid. It is absolutely okay if you just subjectively prove to you that to yourself that the history was valid. And all the details of the history, I can send them to you off chain. The only relevant part is that we need the blockchain as like a time stamping mechanism. And RGB, the RGB protocol, also the Taro protocol, already works with that idea that they just use the Bitcoin protocol as a timestamping mechanism, and all the transaction data is communicated off-chain. However, they don't use validity proofs yet, and that is a fundamental flaw in their systems, because the history of such a token grows quasi-exponentially, because every token has at least one input, it has at least one ancestor. Many of them have more than one ancestor, so on average they have more than one ancestor, and that means it grows like a tree, and trees grow exponentially in computer science. So the history of coins grows exponentially in client-side validation models. However, if you combine them with validity proofs, then you can compress this entire history into a succinct proof. And then you have that nice property that a coin becomes its proof of history. And then I can just give you the succinct coin proof, and that proves to you the entire history of preceding transactions, of transactions that led to the validity of your transaction. And it also proves that all of them were included in the chain, or like were anchored into the chain at the right moments, so that no double spending occurred. And this approach is fundamentally better than ZK rollups or something like Zcash, because Zcash still requires everyone to validate everything. Here you just need the chain for these commitments, that just look like random data to other people. Nobody has to verify them. Only the recipient verifies them. And I think that is very, very interesting, because it gives us like the best of all worlds. Like, it gives us more compact transactions, more throughput. It gives us perfect privacy, even better privacy than RGB does currently, because RGB only obfuscates the transaction amounts, so it's only confidential transactions. It's not like Zcash, where also the transaction graph is obfuscated, which is a fundamentally better thing. And with ZK coins, you get that all for free, essentially, just by approaching it from the right direction. And it just comes from, like, the privacy is just essentially, the perfect privacy is a byproduct of minimizing the on-chain footprint.
Hello, Bitcoin Takeover listeners. This is Victor from IVPN. We could have produced a flashy ad with lofty claims, but we like the straightforward approach, so I'll just stick to the basics here. How are we different from other VPN providers? iVPN is run by Bitcoiners. We've been accepting Bitcoin since before the block size wars, now using BTC Pay server, and also accept Lightning payments. We also aim for radical transparency supported by open source software, regular audits, and a transparent team. And finally, there's absolutely no KYC with iVPN. We don't ask for an email or any other personal information when you sign up. If you would like to test our service, send an email to trial@ivpn.net to receive a 30-day iVPN Pro voucher.
Hello, I'm Vlad and I have been a user of iVPN Pro for longer than 1 year. What I like the most about it is being able to use 7 devices at the same time and using the multi-hop feature to connect to 2 different servers of my choosing at the same time. Also, your account consists of a randomly generated string of letters and numbers which are not linked to your email address, bank account, or real-life identity. You top it up with a Lightning payment and you get instant confirmation at low fees. Definitely get your 30-day iVPN Pro trial by sending an email to trial@ivpn.net. Make sure you use a burner email address that you probably already have for trolling. Yeah, there's so much cool stuff that you can do. And you said something interesting about timestamping, and I think this was my idea initially when I saw BitVM. I was like, oh, so this guy created BitVM and was able to deploy it just like Peter Todd deployed open timestamps. Without anyone's permission, it's just a thing of its own, which operates. If you want to use it, it's out there in the wild, and it can open up a lot of possible use cases. So I'm actually proud that this could happen and someone figured this out without the need for a soft fork.
Yeah, I mean, yeah, that's Bitcoin forces you to do that, right? If it would be too easy to activate soft forks, then nobody would think about such stuff. Other people have thought about similar stuff before. Like I didn't come up with it. Like for example, the MET proposal was very similar. Merkleize all the things, and my approach was mostly trying to do what they are doing without a soft fork, because it was already quite close. Like their approach was already like, what's like the minimum soft fork that we would have to do to activate all the complex functionality on Bitcoin? And so they kind of paved the way.
Yeah, you do have Merkleize all the things among your free references. It's pretty interesting. You have the first reference is Ethereum research on optimistic rollups. The second one is Salvatore Ingala, who published Merkleize all the things back in 2022. And the third one is Jeremy Rubin checks SIG from Stack for 5 byte values, which is a blog post that he used. So you have free references, and these are the ones.
Yeah. Just recently, I added the reference to Jeremy's blog because I realized that I just had a bad memory, and that he actually invented a key concept that BitVM is based on. And yeah, it's actually just Lamport signatures, and he showed how to implement Lamport signatures in Bitcoin script as it is today. And yeah, Lamport signatures are also fundamental to BitVM because a very crucial part of BitVM is to enable state across different scripts. Currently, Bitcoin script is just completely stateless. Every script is independent of all the other scripts. But these Lamport signatures, they allow us to transport a value from one script to another script, from one transaction to another transaction. So I can have a value in some computation that is consistent across one script to another script. And Lamport signatures, as Jeremy has shown, they are very fundamental. Or they actually enable this way of transporting the values across different scripts, which enables the statefulness and all the good stuff.
Yeah, so if I was your marketing director or something, if I managed your marketing, I would tell you the following. If you want to convince the Bitcoiners that you're not trying to attack Bitcoin, remove any reference to Jeremy Rubin, because apparently people thought he was the CIA when he was promoting BIP 119. You're like, no, we don't want this. And now when he went away, people actually started looking into his proposal seriously. And then I would tell you, remove proof of stake from any mention of your research, because that's going to trigger emotional reactions. And people are not going to care about the research itself. They're going to dismiss it based on the use of this specific term. And it seems like you don't care. And that's the part that I like about you the most, because you're pure and you're honest in your research. And you're like, yeah, I think this is interesting. I'm going to look into it. Maybe it will work out, maybe not, but you're just pursuing your own passion. And I respect that.
Thanks.
You're a textbook engineer. You don't care about what others are thinking. You're just pursuing your own curiosity. That's beautiful.
I care about truth because it's what leads you to the interesting things. Like, that's the hard thing. Like, every opinion is off. No opinion is completely true. But trying to have a more true opinion is the interesting direction, I think.
Yeah, Robin, but I'm looking at your profile picture. You don't have laser eyes. You don't tweet about the price. You don't make predictions. You don't say anything about the ETF, that you support it or not. You're focused on proof of stake stuff. And you also quote Jeremy Rubin in your white paper. So you also use BitVM, which sounds like EVM, and that's Ethereum virtual machine. That's shitcoiny. ZKE, zero knowledge proofs, that were used for Zcash and also Ethereum. That's shitcoiny. So many red flags. Are you even a Bitcoiner?
I would say so, but I think even the BitVM idea that was good marketing wise, because a lot of the hype came from people who I kind of feel like secretly admire the buzz that is on Ethereum, and they would like to have that buzz on Bitcoin too. And they saw that thing, or like they saw the BitVM buzz, and then they just thought, there's the Ethereum killer, and then they just created more buzz because they want to see an Ethereum killer. So that was good marketing wise, I think.
No, I agree with that, because that's the thought that everyone had in the beginning. Oh, BitVM, it sounds like EVM. Let's look into this. Maybe this guy figured out how to do the Ethereum virtual machine on Bitcoin. But you do it off-chain. As far as I know, on Ethereum, everything is on-chain.
Yeah. And
that doesn't scale. It's a pretty bad idea.
Yeah, that's definitely true. Ethereum scales poorly. It's like Bitcoin scales poorly, and Ethereum scales much worse.
Which is, I guess, why they spend so much money on researchers and solutions to try to make that invention of theirs scale, because they really want to believe that it can work. And it seems like they did have some interesting...
many reasons. That is actually a very interesting topic, because first of all, obviously they are pouring billions over like all the research institutes in the world, and that helped cryptography a lot. Like, it's probably one of the best funded research areas next to AI. But the even more interesting point I found is even though Bitcoin is based on like ancient cryptography, because like 20 years, 15 years is like ancient in cryptography terms, even though it's based on ancient cryptography, it's still the best. Like, it's still the number one. There is still no other currency that came and was that vastly better that it overtook Bitcoin's first place. And I find that very interesting from a theoretical point of view, that it's that hard to design a better blockchain than Bitcoin is. And I think it would be totally doable to come up with a 10 times better blockchain, but it seems like you cannot easily create 100 times or 1,000 times better blockchain, even if you have $1 billion of research budget or more.
Yeah, I agree with you. And what I like about your work is that you're not afraid to look into this other research and discover stuff that might be useful for this project, which is still king. And
it would be stupid. It's undeniable that they have absolute insane amounts of money that they pour into research, and it would be pretty unlikely that nothing comes out of it that has a value to Bitcoin.
Yeah, I'm going to intellectually reduce the level of this conversation because there's this Eleanor Roosevelt quote that brilliant minds talk about ideas and average minds talk about events and small minds talk about people. But I want to talk about a few people who had reactions to BitVM. And I need to give a shout out to Hampus, the creator of Blixt Wallet. He's super bullish on BitVM, and he mentioned in a comment to one of my tweets that it's the biggest discovery in the history of Bitcoin, and it's also the most promising. And it might be an overstatement, but it's a testament that you did some useful work and other developers are valuing it.
Yeah, that is important feedback to me. I respect his work, and it's always great to get positive feedback from people whose work you respect.
Sadochip provides open source solutions based on smart card to assist you in your crypto journey. The hardware wallet lets you safely store your private keys within the tamper-proof chip memory, while Sado Dime allows you to create a barrier cold storage in 2 clicks thanks to its mobile app. And Seedkeeper is the ultimate hardware device to store and manage your seed phrases. Become self-custody with Sadochip. Your keys, your coins.
And there's also David Bailey from Bitcoin Magazine. He is the owner of BTC Media. And I had a brief conversation with him, and he told me something along the lines of, I'm super proud of the new generation of Bitcoin developers, and he name dropped you and Super Testnet as examples. He said, Robin, Linus, and Super Testnet, super brilliant guys, and I'm very bullish on everything they're building.
I'm very happy to hear that.
Yeah, maybe squeeze him for some funds, ask him for whatever idea you might have. Make him pay for it.
Yeah, he tweeted that we should just fund any company and he would invest 10 BTC, even if it was just like a sandwich company or something.
You want to make a sandwich company?
No, he said even if it would be a sandwich company, he would invest immediately just because he likes our work so much.
Yeah, but I was more alluding to the fact that you can exploit this. There's a bug in the contract. He basically set the limit very low, so you can start a sandwich company and take the 10 BTC. No questions asked.
Yeah, I don't know. Yeah, lots of people are suggesting that we should found a company. I don't quite know how I feel about this. Currently, ZeroSync and BitVM is funded by grants, by research grants, and that has upsides and downsides. Of course, we are very limited in comparison to commercial things, but on the other hand, it's just us. It's the ZeroSync team who mostly do it for fun, or because we love it and because we really believe in the cause, and it's a filter. We definitely have no people around who are in it for the money, because there is no money in it. So that is a very, very good filter, and I think it's very healthy for the culture in the team. And I'm not sure if it would be easy to sustain that if we suddenly had lots of money to build a company. And it's not easy to make a decision between growing much more quickly and making maybe much more impact, and on the other hand balancing that great filter of working only with people who really believe in the cause, because otherwise they would work somewhere else where they earn more.
I think this last statement is what makes you a true Bitcoiner, because in the Ethereum land, it's all about launching a token and getting stupidly rich because people believe in whatever you're building and say, yeah, I'm going to buy the token, I'm going to pump it, and then you can sell some and you can spend the rest of your time coding from a Lambo or something. But you don't want that. You see it as a potential obstacle in the way of you achieving the goal that you want to achieve. You're even reluctant to the idea of starting a company for the sake of raising funds. You just want to focus on your work. And I think that's an important distinction that appears in the case of Bitcoin developers. You don't care much about the money side of it. You just want to get the research done and make Bitcoin useful for what you believe it should be doing. And that's why I respect your work.
Yeah.
I mean, not just that.
World, right? First initial contact was with Bitcoin, but then I had my experience in shitcoin world, and I had my experience with like an ICO company and all that stuff, and I saw how toxic that can be, and I saw how it turned good engineers into assholes, and like building mock-ups. Yeah. It hurt my engineering heart so much that I'm kind of traumatized by that, so that I shy away from it, because I've already experienced how painful it is. So that's the reason. And I thought it would be great initially, and I learned that it's not great.
Yeah, generally it's a bad idea to get paid before you get your work done. Because if you get stupidly rich, money brings problems that you previously did not have. And even if you're if you're frugal and you don't spend much, you still have to spend money on managing that money that you receive from investor. You still have to spend some money on accounting and proving to the investors that you're doing what you said you would be doing. So it's still a waste of mental energy and effort and resources just to manage that. And in the Bitcoin space specifically, you can build and deploy stuff without worrying about legal entities, you know? You don't need to start a company to become a developer. Just need to ship code and make people run it and prove that it's useful. And then you get donations or whatever. Yeah. And you can sustain your work. And that's pretty cool if you become popular, because you can also be on the other side of the spectrum, spend all of your time building stuff that nobody wants to use or nobody is interested. And it can be painful. And that, I guess that's what leads people to creating some sort of altcoin, because they want to prove that their idea can work. And they need some sort of incentive to prove that, to get rich or whatever. But yet generally receiving money, the ICO model is broken, because when you get money before you actually get any work done and you just have a roadmap and you promise people, yeah, I'm going to do this in the next few months and then I'm going to do that and blah, blah, blah. Most of the times it never happens. And
people start telling themselves that that there is that much money because their work is so valuable, which is totally not the case. Like, there is so much money because the market is so crazy and is giving so much money to people that have not created any value yet at all. But once an ICO company has that money, they justify to themselves why there is so much money, and the reason that they come up with is that their work is so great. And that is like the best way to do horrible work, because if you're not capable of judging your own work anymore, it will be shitty. Most likely it will be shitty. It's very unlikely that it will be great work if you're incapable of judging the value of it.
Yeah, but at the same time, we also have to realize that at the end of creating something great, we have to reward ourselves somehow, because otherwise we're going to be miserable. Which is why I promote the Supra cycle. What do you think about the Supra cycle?
What's the super cycle? It's like every 4 years it goes up, and then like every 16 years or whatever it goes even higher. Or what? What's the super cycle?
Supra cycle, as in Toyota Supra.
I don't get it. Sorry.
Okay, you're thinking about the super cycle, which is the theory that we might have this bull market that never ends.
Yeah.
That's the hypothesis. But I'm describing the supra cycle, and let me figure out a way to share the screen with you so you can see this. So Twitter. Basically, the idea is that
I have that appointment.
Oh yeah. I'm gonna finish fast. I just want to show you the supra cycle, and then we can wrap this up. So the supra cycle is this idea that Bitcoiners want to get a Lambo, right? But Lambos are super expensive, and it's kind of a bad idea to get one. And what is the car that's 90% of the Lambo at about 10% of the price? And the answer is the Toyota Supra. And I came up with this, if you can see it.
Okay.
So on the left side, you have the bullshit narratives that failed, like stock to flow and super cycle. And on the right side, you have an actual linear model that makes sense. This is the way to 100K. It's going up. And sometime, according to this model, sometime in September, we're going to be at 65-ish thousand. And that's a moment when you can buy a brand new Toyota Supra with 1 Bitcoin. And with 1 Supra, you get 1 girlfriend. And
it reminds me of that ad of Daihatsu or so. I think it was Daihatsu. They have they have that minivan, and it said the ad said picks up 6 times more girls than a Lambo. So there's more space in there. Like a Lambo has only space for 1 girl, and the Daihatsu has space for 6 girls, and it was that. I don't know. So you should better buy a Daihatsu.
I'm a Supra guy, so 1 girlfriend, 1 Supra. I think it's enough to make your life better after the next bull market. If you ask me, it's much better than huddling for no purpose, because you're creating purpose. You get a girlfriend and you have a nice car. Take it from there. Start a new life. Don't just wait for something that may never come, or be undecided for the rest of your life, because you're gonna get old and grumpy.
That's true. It's good advice.
Yeah, anyway, I know your opinion of it now. You think it's good advice. I'm gonna let you go. This was super informative, and I didn't even get to ask you about your work at ZeroSync, maybe some other time. But you did mention some of that stuff that you want to do. What's it called? ZK Bit or something like that?
Yeah, I talked briefly about ZeroSync, but yeah, unfortunately, I really have to leave.
Yeah, I know.
Late for my next appointment. Sorry.
Yeah, it's fine. So thank you very much, Robin. You can follow him on Twitter and stuff, and I'll let you go. Bye.
See you. Bye.